Now we will discuss about the deadlock. So the deadlock is the situation where the process is waiting for a resource which is already held by the another process. Consider this example. We have a two process P1 and P2 and we have a two resource R1 and R2. The R1 has been already allocated to P1. Okay. The P1 is requesting the R2. The R2 has been already allocated to process P2. The P2 is requesting R1. The P1 cannot get the R1 R2 till the P2 releases. The P2 cannot release the resource R2 till it gets R1. So it forms a cycle. So this situation is called as deadlock. So the thread may utilize the resources in the following order. First one is first it need to request for resources. Then once the resources has been allocated, the thread utilize that resources. After usage, it has to release that resources. All the three things are happen by using the set of system calls. So if it is a device, request for a device, so it will be a request and a release. If it is a for a device, the set of system call is. If it is a file, it will be a open and close system call. If it is a file. So if it is a memory, so the system call used is allocate and free. If it is a memory. Okay. So next we discuss about the four conditions of deadlock. So a deadlock situation can arise if the four conditions hold simultaneously in the system. Four conditions should be happen simultaneously in the system. Definitely it will be a deadlock. The first one, mutual exclusion. It means that only one process can enter into a critical section at a time. So only one process can be enter into a critical section at a time. The remaining process needs to wait and hold and wait. So one process is the waiting, holding a resources of holding a resource. Another process is waiting for that particular resource which is held by the another process. That is called as hold and wait. Next, no preemption. Okay, even though high priority process comes once the process has been allocated to a CPU, till it completes its execution, it cannot be preempted from the CPU. That kind of process is called as no preemption process. Then circular wait. Consider here, consider a set of process T0, T1, etc. up to Tn. So consider a set of process of wait set of waiting thread. So the T0 is waiting for resources held by the T1. T0 is waiting for the resource held by T1. The T1 is waiting for the resource held by the T2. The T2 is waiting for the resource held by T2, etc. The Tn is the waiting for the resource which is already held by the T0. So that is called as the circular wait. So if all the four situations simultaneously happen in the deadlock, so happen in the system, it leads to a deadlock. Next one, resource allocation graph. So the desktop can be described in terms of directed graph called system resource allocation graph. So it is a directed graph. Hmm. Called a system resource allocation graph. So it consists of set of vertices, set of vertices V and set of edges E. set of edges V. So first we see what is there in the vertices. Okay. So in the vertices we have a so set of threads. The T is a set of thread. T1, T2, T3, etc. Tn. It is a set of active threads. Then R is a set of all resources. So R1, R2, etc. Rn. Then you also need to consider that, for example, if there are four CPUs, okay, we have a four CPU, it means then the CPU, you have to tell that the CPU with four instances. If we have a two networks in a system, so the network with two instances. Okay, well, this is what you have to mention the resources. Then edges. So this is the request test. The thread TI is requesting for resource RJ is called as request stage. Now consider this. The resource RJ has been allocated to the thread TI. This is called as assignmentage. So the resource has been assigned to a thread, that is assignmentage. So that is request stage and assignmentage. Now to draw the resource allocation graph, we need the set of vertices and edges, and for each resources how many instances are there, that we need to, that details we need to have. So consider here. So we have a following details are given. So set of active threads. So we have a three threads T1, T2 and T3. Then we have a set of resources R1, R2, R3 and R4. These are all the set of resources and set of edges. So the T1 is requesting R1, the next edge is T2 is requesting R3, then R1 is allocated or assigned to T2, R2 is assigned to T2, R2 is assigned to T1 and R3 has been assigned to T3. So with these details we also should know the number of instances in each resources. That is one instance of resource type R1 and two instance of resource type R2 and one instance of resource type R3, then three instance of resource type R4. Okay. So for this given details, we need to draw the resource allocation graph. So first, how many number of threads are there? Three. So we draw like this. So this is the thread 1, thread 2 and we have a thread 3. Okay. And we have a 4 resources. So that for that we need to we need to represent the threads using that circle the resources using the rectangle box. Okay, so consider this as a resource one. It having the only one instances. For that you need to keep a dot for each instances inside the rectangle box. The R3 is also having one instances. Then the R2 is having the two instance. Okay. Then the R4 is having the three instance. Now draw the edges. T1 is requesting for R1. Okay. T2 is requesting for R3. Okay. Now the R1 has been allocated to T2. So the R1 has been allocated to T2. Next, R2 has been allocated to T2. Okay. Then R2 has been allocated to T1. Next, R3 has been allocated to T3. Only one instance. So it has been allocated to T3. That's all. So this is the resource allocation graph for the above given detail. Okay. Here, is there any possible way for deadlock in this resource allocation? No. For example, the R3 is already holding the resource R, the thread T3 is holding the resource R3. If it releases, it's not waiting for any other resource. So once it completes its execution, if it release the resource R3, the T2 will get the resource R3 and it complete its execution. Once T2 complete its execution, it release the resource R1, then T1 completes its execution. So here there is no cycle and also there is no deadlock. Now consider here I add that one more edges, that is T3 is requesting for R2. Now consider T3 is waiting for R2. Now there is a cycle and it is also a deadlock. Here there are two cycles has been formed here, that is T1 to R1 to T2 to R3 to T3 to R2 to T1. This is one. Another one is the T2 R3, T3 R2 and T2. See here, the T3 cannot release the resource R3 till it gets R2. The T2 and T1, the T2 cannot release resource R2 till it gets R3. The T1 also cannot release resource R2 till it gets R1. So all the three threads need to be holding some resources and waiting for resources. So there is a cycle and here there is a deadlock. So I show you the another example. Even though there is a cycle, okay, in the resource allocation graph, but there is no deadlock there. Okay. Now consider this resource allocation graph. So we have two resource R1 with two instances and R2 also with two instances. Okay, we have a four thread T1, T2, T3 and T4. Okay, so the T1 is requesting resource R1. The R1 has been already allocated, one instance of R1 has been allocated to T2 and one instance of R1 has been allocated to T3. The T3 is requesting for resource R2, but one instance of R2 has been already allocated to T1, another instance of R2 has been allocated to 2. So here the cycle is T1, R1, T3, R2, because here all the threads are not added in the cycle. So the R1 will be available once the T2 has been released the R1. The T2 is not waiting for any other resources. So it can complete its execution and release the R1. Like that, the R2 also has been released once T4 has completed its execution. Because T4 is also not waiting for any other resources. Once it completes, it releases the R2. So automatically the R1 get the T1 gets the resource R1 after T2 completes or releases. Like that, T3 gets the resource R2 once T4 completes its execution and releases the R2. So this is the example for resource allocation graph with cycle but no deadlock. So resource allocation graph with cycle but there is no deadlock. Thank you.